The third and final way of solving systems is by using a method called elimination. In elimination, we're not going to be substituting something in for something else. We're going to be looking for opposites. So here are some steps that you can review about solving systems by elimination. We're going to come down here and look at example number 1. Remember, you're looking for opposites. Positive 1 and positive 1 are not opposites, but positive 1 and negative 1, the coefficients on the y's, those are opposites. And so sometimes when you're doing elimination, remember, you're looking for opposites. Opposites is the big thing on this. Sometimes they have opposites right away. So on this one, the y's cross out with each other. When you do elimination, you then add up what's left over. 1x plus 1x gives you 2x. Negative 4 plus negative 14 gives you negative 18. And then you divide both sides by 2, which gives you x equals negative 9, which is part of your answer. Once you have the answer for part of your answer, you're going to go back and you're going to plug it in for either the x up here or the x up here from before you crossed out the y's. It doesn't matter which equation you plug it into because you're going to get the same answer for both of them. I'll plug it into the first one. So negative 9 goes in for the x, plus y is equal to negative 4, and then I'm going to solve for y. So I'll add the 9 to both sides. I'll get y equals 5, and then that's the second part of the answer to my question. If I were to graph these two lines to find the point where they cross, they would cross at the point negative 9, comma, positive 5. And again, if I plugged the negative 9 into this equation instead, I would get the same answer. So when you solve a system by elimination, you're looking for opposites. 2x and 1x are not opposites, but negative 3y and positive 3y are opposites. And so when they're opposites, you cross them out, and then you add up what's left over. 2x plus 1x gives me 3x. Negative 4 plus 7 gives me positive 3, and then I'll divide both sides by 3, and I'll get x equals 1. So on this problem, x equals 1 is part of my answer. Once I know that x equals 1, I can either plug it in up here for this x in the first equation, or I can plug it in down here for x in the second equation. It doesn't matter which one I plug it into. I'm going to plug this one into the second one. So I'll plug in the 1 for the x, and then the y stays y when you plug it in. And then once you plug it in, you go through and you solve to figure out what the y is equal to. So minus the 1 from both sides, and then divide by 3. And so for this one, you get y equals 2. So if you were going to graph these two lines, the point where they cross would be the point 1, 2. Sometimes when you solve a system by elimination, there's not going to be opposites. So looking at example 2a, positive 2 and positive 2 are almost opposites, just not quite, because they're both positive. And then positive 6 and negative 1 are not opposites, but they could be if you made them be opposites. And so when there are not opposites, you need to make there be opposites. And so that's what you're going to try to do on this one. You could multiply either of these equations through by something to create opposites. If you wanted to, you could multiply this second equation through by a negative 1. That would make the x's be opposites. Or, if you wanted to, you could multiply the second equation through by a positive 6. That's how I'm going to do the notes today. If you multiply this equation through by a positive 6, you'll multiply here, here, and here. So you have to remember to multiply all three parts of it. But a positive 6 times a negative 1 is going to make this term turn into a negative 6, and then it will cross out with the numbers up above. So when you do that, you're going to use the distributive property. And so that's what I've gone ahead and done right here. My first equation stayed the same, and I rewrote it. And then my second equation turned into 12x minus 6y is equal to negative 48. Once I've gone through and done that, then I'm going to cross off the opposites. So here the y's cross off. And then you add up what's left over. So 2x plus 12x gives me 14x. And negative 6 plus 48 gives me negative 42. And then to get the x all by itself, I'm going to divide both sides by 14. So I'll get x equals negative 3. X equals negative 3 is going to be part of my answer. To solve to find the other part of my answer, you can plug x equals negative 3 into the first equation right here, or you could plug x equals negative 3 into the second equation right here. But you want to plug it into either of the two original equations that you started with. So I'm going to go ahead and I'm going to plug it into the first equation. So I'll replace the x with negative 3, and then rewrite the rest of the equation, and then I'll go through and I'll solve for x. So I'll multiply and then I'll add the 6 to both sides. So 6y equals 12. And then I'll divide both sides by 6. And when I divide both sides by 6, I'm going to get y equals 2. So if I were to graph these two lines, the point where they cross would be the point -3, positive 2. And I found that answer using elimination. I had to create opposites in this one, but it's still considered elimination even if you have to create opposites. On question B, you also need to create an opposite because 6x and 2x, those are not opposites. And then positive 4y and positive 4y, those ones also aren't opposites. So you can multiply either equation through by something to create an opposite. If you wanted to, you could multiply the second equation through by -1. If you multiplied it through by -1, that would make the 4y's turn into opposites of each other. Or if you wanted to, you could multiply the second equation through by -3. And that's what I'm going to do on this one. You can multiply through by whatever you want to. A lot of times students want to know, where does this number come from? You think of that number by deciding which variable, x or y, you want to make be opposites. And then once you decide which variable you want to be opposites, you think about what would I have to multiply a positive 2 by to turn it into the opposite of positive 6. So if positive 6 is positive 6, the opposite would be -6, and so you would have to multiply your positive 2 by a -3 to make those be opposites. Remember, when you do this, your first equation stays the same, and then when you do the second equation, just don't forget to do the distributive property for all of the different parts. You want to make sure that you don't forget the sign on a number. So when I'm done multiplying on this one, it'll be my x's that cross off because I chose to have them cross off. -8y is equal to positive 16. Divide both sides by -8. So for this one, I'm going to get y is equal to -2. Be careful when you write your answer. That means that your y value is -2, not your x value. So you want to make sure to put that number second. And then you get y is equal to -2. So now you're going to come back up, and you can either plug it in here for this y, or you can plug it in here for this y. Either way will give you the right answer to the question. It doesn't matter which one you work with. I'll plug this one into the second one. So 2x plus 4 times the -2 that you just got as the answer for your y. 2x minus 8 equals -2. And then you'll just go through and finish solving for x. So 2x equals 6. And so that'll give you x equals positive 3. And so if you were to graph the lines, this point right here, positive 3, -2, would be the point where those two lines cross. On question C, we have a little more work to do because 3 and 2 are not opposites, and -5 and -7 are not opposites. And so on this one, we're going to have to do a little bit extra to make them be opposites because we can't just multiply one equation through by something. On this one, we're going to have to multiply both equations through by something to make them be opposites. So you could either make the x's be opposites or you could make the y's be opposites. Sometimes people like to pick the one that has the least amount of work. I think the numbers 7 and 5 are kind of big, so I'm going to do with the numbers 3 and 2. The smallest number that I can make a 3 and a 2 both turn into is the number 6. So I'll multiply this one through by -2, and I'll multiply this one through by positive 3. You could also put the negative on the 3 if you wanted to instead of on the 2, or you could multiply them through by a positive 7 and a -5, or a -7 and a positive 5 to make the y's be opposites. This is just the way that I'm choosing to do the problem, but there are other ways that you could pick numbers that would give you a correct answer to the question. Remember, when you do the distributive property, you just want to be careful to not forget to multiply any of the parts. So on this one, I carefully did the distributive property. I went back and I checked all of my signs to make sure that I didn't make any mistakes on my signs. My x's are opposites, so my x's cross out. I'm going to get -11y is equal to 0. And then when I divide both sides by -11, I'm going to get y is equal to 0. So on my answer, my y is 0. And then to solve for what my x is equal to, I'm going to come back up and I can plug 0 in for either of the equations. I'll plug mine into the second one. So 2x minus 7 times 0 is equal to -4. So 2x is equal to -4. So I'll get x is equal to -2. If I were to graph these two lines, the point where they would cross would be the point -2, 0. And then lastly, on problem D for this page in the notes, you don't always have to multiply both of the equations through by something. And so we did this one here because we wanted to make sure that you saw that sometimes you have to multiply both of them through by something, but sometimes you don't. And so you could make both of these turn into 12s, or you could make both of these turn into, what would that be, 48. But sometimes there's a shorter way to answer the question. On this one, I'm going to multiply this last equation, the second equation, through by positive 3. Because that's all I need to make the y's, or the x's in this case, turn opposite. So when you're choosing your number, don't do more work than you have to do. You want to try to pick the smallest number you can pick to multiply through by. And so on this one, my top equation will stay the same, and it's only my bottom equation that'll change. So I went ahead and did the distributive property. I multiplied everything in the second equation through by a positive 3, and then look what happens on this one. Something different happens. My x's cross out, my y's cross out, and my numbers over here, my constants, they cross out too. So what I'm left over with is 0 equals 0. Remember back to the substitution notes, you have to ask yourself, does 0 equal 0? And in fact it does. And so that's a check mark. The answer to the question for this one is many solutions. So when the x's and the y's both cross out, and when what you're left over with is a true statement, 0 equals 0, that means that the answer to the question is going to be many solutions. If these two numbers were different, like if this said 0 equals 18, for example, then the answer to the question would be no solution. Since we've already done an example of many solutions, we're going to skip example A on this side. We're just going to move down and we're going to do B and we'll do C. On B, you want to make them have opposites. So let's see, I'll make the x's be opposites. I don't have to turn both of them into 27 because if I want to, I can just multiply this one through by negative 3. And that will make the x's turn into negative 9, which would be the opposite of positive 9, and then they'll be opposites. So 9x plus 12y equals 15. Remember, the first equation stays the same in this case. And then negative 9x minus 12y is equal to positive 9. In this problem, the x's are opposites and the y's are opposites, but the constants, the numbers over here, they're not opposites, so they don't cross off. You get 0 equals 24. And so remember, the x's crossed out, the y's crossed out. What you're left over with is not true, it's false. And so that's when the answer to the question is no solution. If you were going to graph these lines, they would be parallel to one another, they would never cross, and so the solution to the system would be that the system does not have a solution. The answer would be no solution. On example C, let's see, how about I cross the y's out on this one first? I'm actually going to multiply the first equation through by something on this one. To make the y's be opposites, this one's already negative, and it's a 4. So to make the y's be opposites, I would multiply this one through by a positive 2, because that would make the y on the top turn into positive 4. It would be the opposite of negative 4, and then my y's would be the ones that cross out. So my top equation would turn into 2x plus 4y equals negative 16, and then the bottom equation stays the same on this one. And then I cross out my y's, so I'm going to get 5x is equal to negative 40, and then I would divide both sides by positive 5, so I'm going to get x is equal to negative 8. And so this example is included in this second set of problems because you don't want to always think that both of them is going to cross out. Usually only one of the variables will cross out when you make it have an opposite. X equals negative 8 means that negative 8 is part of my answer, and now I just need to figure out the other part of my answer. So I can plug it into my first equation, or I can plug it into my second equation. On this one, I'm going to plug it into the first one. So negative 8 plus 2y equals negative 8. I'll add the 8 to both sides. Don't be worried that the 8's cross out on this one. It's okay to get 0 as part of your answer. That's actually why we included it here. So y is equal to 0 means that 0 is part of your answer. When you get 0 here for your y, don't think that 0 makes it be no solution. No solution or many solutions is when the x's and the y's both cross out, and when what you're left over with is either true or false. So on this one, you're left over with, you can solve for x and y. So x equals negative 8, y equals 0. If you were going to graph these two lines, they would cross at the point negative 8, 0. Systems of equations can also help us solve word problems. In this first example, the equations have been created for you. She spent $16.30 to buy 16 flowers, daisies and tulips, and you're being asked to determine how many of each type of flower did Jessica buy. So if you look at the problem right now, it's set up in such a way so that you could do elimination with it if you wanted to. You can multiply your first equation through by negative 1.75, or you could multiply your first equation through by negative 0.85. It doesn't matter. I'll do negative 1.75, but you could multiply it through by either one. Just remember, when you do it, you're going to need to do the distributive property. So I do the distributive property on the top. Negative 1.75d minus 1.75t is equal to negative 28. And then once you've created your opposites, you're going to add up what's left over. So these will cross off, and then you'll do 1.75 minus 0.85. Remember, they're opposites. So this is going to give you negative 0.9t is equal to, and then 28, take away the 1630, is going to give you negative 11.7. And so to finish, you'll divide both sides by negative 0.9. And so you're going to get t is equal to 13, which is part of your answer to the question. Remember that they wanted you to figure out how many of each type of flour did she buy, which means you have to go and plug in the 13. I'm going to use the first equation because it's much easier, but you'll plug it back in to find the other answer to the question. So d plus plug in the 13 for t is equal to 16 minus the 13 from both sides, and so you'll get d equals 3. The answer to the question you can write out using words. So for this problem, she bought 13 tulips and 3 daisies, given the constraints in the problem. On example number 5, you have to read the words to the question and come up with the equation yourself. Jane has 36 coins totaling $3, and they're all nickels and quarters. How many of each coin does she have? So she has n nickels and q quarters, and it says that she has 36 coins altogether, so that would be your first equation. Nickels are worth 5 cents, and quarters are worth 25 cents, and altogether she has $3 total in money. So creating the two equations is your first step in solving this. Once you have the two equations created, then you want to decide what you're going to multiply by to cross off. On this one, you're solving for both, so it doesn't matter which one you multiply through first. Let's see. I'll multiply this one by negative 0.25. That'll make the q's cross off. And so I'll be careful when I do the distributive property that I multiply it to all three parts. I double checked my distributive property, and so on this one we're all set with the distributive property. Remember, once you do the distributive property, then you're going to cross off your opposites. You'll add up what's left over. So this is going to give me negative 0.2n is equal to negative 6. And then to finish, I'll divide both sides by negative 0.2, and that'll give me the answer to the question. I ran out of space a little bit here, so I'm just going to write the answer next to it. So n equals 30. So 30 nickels is how many coins she has in this example. Now I need to go back and figure out how many quarters that means she has. And so again, to find that, I'm going to plug it into this first equation because the numbers are so straightforward. So 30 gets plugged in for n, plus q is equal to 36 minus the 30 from both sides. And so q equals 6 is the other answer to the question. Remember, with word problems, it's best to write your answer in words. And so for this example, she would have 30 nickels and she would have 6 quarters if she had 36 coins and $3. When you're solving these problems, you can decide what letters you want to use. In this example, the family's ordering banana splits and hot fudge sundaes, and so I'll use B and H for my letters, but you could use other letters as well. 2 banana splits plus 2 hot fudge sundaes is $18, and then 5 banana splits and 2 hot fudge sundaes is $36. And so you're trying to solve this system to figure out how much each of the items cost. So you are solving for both of the variables in this problem as well. Let's see. I could make my 5 and my 2 be opposites. Or on this one, if I wanted to, I could just multiply through one of the equations, either one, by a negative 1. I think it would be good to do an example like that today too. If you have two numbers that are the same number, you could always multiply one of the equations through by a negative 1 to make that equation be opposites. So negative 2b minus 2h is equal to negative 18. My first equation just changes by the sign. And then here's my second equation. And then remember, once you've created the opposites, you cross off the opposites and you add up what's left over. 3b is equal to 18. So b is equal to 6. So in this example, each banana split costs $6. And now I'll plug that back in to either of the two original equations to solve for how much the hot fudge sundaes cost. Let's see, 2 times 6. I'm plugging it into the first one because the numbers are just a little bit smaller. I'll minus the 12 from both sides. 2h equals 6. And so h equals 3. And then remember, you want to write your answers to the word problems as words. And so to wrap up this final example, each banana split costs $6 and each hot fudge sundae would cost $3 based on the constraints that are given in the question.